All right, Chris, I think we are good to go. We are streaming, audio's out, we are recording, so we're good.
Very good. All right. Good morning, good afternoon, everybody, and welcome to another DIY-RoboCar's virtual race. Today, we are going to have, I think we have 28 racers, which is a lot. Most of them, but not all, are from the University of California, San Diego, and that's not a coincidence. It has a lot to do with our track master today, Jack Silverman, who's a professor there at UCSD. Jack, good morning, and thank you for this, and welcome to you and your team. What do we have to look forward to today?
Morning, Chris. Good morning, everybody. So this is part of a requirement for a class that we teach at UCSD. They are doing this for about 1.5 weeks. Had a quick dry run earlier this week. So I expect that at least people will complete 3 autonomous laps. And then after this, Chris, we go for something that's called from simulator to real life. Then we'll, as we speak, building the robots, and then what they learn on the simulator will be applicable to physical robots.
Terrific. So this is, again, during COVID, we've been doing a lot of virtual racing. We do this monthly. When we can resume in-person racing, hopefully in spring this year, we'll be doing that locally at the various local DIY-RoboCars chapters around the world. Obviously, some will be at UCSD, and then we have our Bay Area one at Circuit Launch in Oakland, where we'll be seeing how well these models work in the real world. The real world introduces challenges with lighting and shadows and all sorts of noise. Simulators are fantastic for training, but they're too perfect. We have sort of perfect information, and the world is imperfect. And so this is building the models and focusing on things like behavioral cloning and reinforcement learning, which we'll talk about later on. And then as we switch to the real world, people are going to have to deal with noise and more robust models that can handle varied environments. All right, so our first 2 racers, Albert and Jacob, are on the line already. They've chosen the same body. You may see over time that other people use different colors and shapes. It's purely aesthetic. It doesn't have any impact. But we will get started. Just for the way this works is that they're going to be, I'm going to say on your market set go, they're going to press a button to put their cars into auto mode. And at that point, it's hands off. During the race, they'll talk about their techniques, but the cars will autonomously go around the course 3 times if possible, avoid each other if possible, and their times will be recorded. At the end, the fastest 8 cars will progress to a ladder, and then we'll find out who's the fastest car overall. So racers, are you ready? You can say yes.
Ready.
How do we gonna do the inside lane? That will be Albert, kind of look like on the left on the screen, but I do inside, I do Albert, and then you do Jacobs, and from now on we all do the same, right? You do the inside lane, you do the outside lane.
Yep.
Okay. Racers, Albert and Jacob, please unmute because I'm going to ask you to describe your techniques. Racers, are you ready?
Ready.
Timers, are you ready?
Yes.
Yep.
On your mark, get set, go.
Oops.
There we go. Excellent start. So we have 2 cars starting at the same time, which is a nice, it doesn't always happen, but you can see right now both can steer and both seem like they're on track. So let's start with you, Albert. You seem to be in first place right now of the 2. What's your technique?
My technique is I tried, when I was training the robot using Donkey AI, I just tried to stay on yellow line as much as possible because I was informed that that has a most distinction in color, so it's easier for the model to follow. So I went for more, like my car is on 0.5 speed, so it's more a better safe than sorry strategy.
Exactly. So this first one is a conservative one to get points on the board. Jacob, you had a slow start, but you have then, I spoke too soon. You then bolted ahead of Albert and then hit a cone. So Jacob, what's going on?
Yeah, so I didn't go as conservative as a start, I guess, but yeah, my strategy for training was the main adjustment I made. I just decreased the sensitivity of the joystick for when I was collecting data because the default was a little twitchy. So, but it looks like it just slipped out on that turn. Don't know exactly what happened there.
So both these racers used what we call behavioral cloning, which is to say that they drove the car manually for a number of laps, and the software records the inputs from their sticks, might be a gamepad or keyboard, and compares that with what the car was seeing, the sort of virtual camera that it gets from the simulator. It then gets the pairs of data, the frames of imagery and the stick inputs, sends them up to the cloud, AWS probably, and then trains a network to learn from what the driver did when the car saw certain things. Then the car, that model, that inference layer is then downloaded, and then the car runs that autonomously. So what you're seeing is the car attempting to recreate what it saw a driver do. But it's not perfect because of course the car is seeing different things. So I believe, have we had our 3 laps?
I'm getting to it right now.
Okay, so that is the 3rd lap. Albert completed 3 laps. Just barely. Jacob got at least 1 lap, possibly 2. So we're going to put the times in. So timers, if you could just enter in their 1 lap and 3 lap times. The best 1 lap time is going to be what advances them to the ladder, if they do in fact go. I'm waiting for these entries in. While we're waiting for that, could, Albert and Jacob, could you please log off the server, and Brandon and Brett log on? Okay, so we're looking at 36. So in this instance, I believe that the Albert had a 36.3 best lap. Jacob, we're waiting for this entry to come in. Jacob had a 37 second, so Albert's slightly faster, it appears. Maybe Jacob didn't finish his lap 2 and lap 3. Doesn't matter. He's got points on the board. All right. Next up, Brandon and Brett. Racers, are you ready?
Yes, sir. I think so.
Timers, are you ready?
I'm ready. How do I'm doing, Brett? Just one more time. I'm in the side lane.
Okay.
On your mark, get set, go. Okay, here you can see coincidentally, the racers chose the same color, but once again, heading off to a strong start. Brett on the inside lane has a slight advantage, but we'll see. But we'll see whether that holds up. Brandon seems to be pulling ahead. Brandon, now that you're in the lead, tell us what your technique is.
Okay, so originally I had my roommate drive randomly, and the model and data did not turn out very well. So I deleted everything, and then I just tried to follow the yellow line and stay in the center again, and just be very meticulous about, like, if I left the yellow line, I'd try to go back to it. And
Terrific.
it seemed like that data quality was better in the model.
So in this case, although a racer might be going for the racing line, you went for the yellow line on the grounds that it gives you higher probability of staying on the track?
Yeah, I just wanted to finish 3 laps.
No worries. Okay, Brett, what's your technique?
So this is probably my 3rd model I've done. This one, I just tried to stay within the lane. So the first few laps, I kind of bounced between the two, the middle lane and this right-hand lane here, or line, excuse me.
Mm-hmm.
And so that's what the goal of this racer here is. If he crosses the line, I always tried to brake and then just come back into that lane. And then I tried a couple other ones. We had a dry run earlier on Tuesday. I tried a different model. I saw a lot of guys were taking up the whole track. I tried that out, and it didn't actually work for me. So I had to revert back to this lane racer where I stayed within the lane.
Well, we have a very exciting collision right here. So you guys were so well matched that you actually ended up neck and neck and collided with each other, and you both went off the track, which is fine. You got points on the board. So let's see how you do. Timers, that is, did not finish for the 3rd lap, but let's put some numbers on the board. Brandon, your first lap was a 39. Brett, your first lap was a 38. Brandon, you had an excellent second lap of 34. That puts you in first place right now overall. And Brett, you had an excellent second lap as well of 35. That puts you in second place. So you guys both did great, and I guess nobody finished their third, which is fine. Okay, moving on to Jesse and Yvonne. By the way, James and Aldo, you'll be next up, but Jesse and Yvonne, so Brett and Brand, if you could log off. Jesse and Yvonne, if you could log on. Excellent. Thank you everyone for doing your dry runs earlier. This is, we've got a lot of racers to go through, and I'm really pleased to see it all moving so efficiently. Okay.
Yeah, currently logging on. Mine's just taking a bit.
No worries.
It usually does.
You're
usually
there.
8 to 10 seconds of a lag.
Yeah. Okay. Timers, are you ready?
I'm ready, doing Jesse.
Okay. Racers, are you ready?
Oh wait, Jack, you're doing
Ready.
Jesse?
Yeah, because inside lane. Remember, not what you have on the screen. Look at all's in the lane because it keeps changing.
Cool.
Okay. Racers, are you ready?
Ready.
On your mark, get set, go. Okay, whoever starts off first, I'll ask you to. So Jesse, you were first off the gate. Tell us about your technique.
Yeah, so I took a different approach where I actually trained my model on the right side and also on the left side. So once I trained it on that, I ended up gathering a bit more data as well. And I retrained it on that as well, such that whenever my robot ran or started from the right side or left side, at some point, it would converge at the center. So it wouldn't really know the difference between where it started. So if it goes on the left lane, it will maintain the left lane for a good while. And then if it switches at some point to the right lane, it will try to maintain at the right lane for a while as well.
That's very smart. So that's what we call domain randomization, creates a more robust model. Looks like you're going backwards. Is that right? Anyway, it doesn't matter. So this technique, when you log onto the virtual, onto the network server, a simulated environment. If you're doing it on your own, you're probably always going to be in the same lane. But if you're doing it in a race, you're randomly assigned to one or the other. So you need to be prepared to start with the right or the left. We might in the future make you go counterclockwise. So randomizing your domains creates a more robust network and is a smart technique overall. Yvonne, what was your technique?
So at first I trained starting from the right side, and I just made sure to stay in the middle. But I was actually hitting the corners like barely. So I actually used the model transfer to start on the left side and did like extra 40 laps. And that seems to make my car like stay in the middle.
Can you tell us a little bit more what model transfer is?
So it's like after I make the first model and I'm not that satisfied with it, so I collect extra data and then add it on to the training.
Got it. Terrific. Okay, well, you guys are both doing really well. I think they both finished their third lap. I think they have.
Yes, we did. Chris, what is the code that we use for the lap that it didn't finish?
DNF did not finish. DNF.
Yeah, one of the laps will disqualify on that particular lap, but he cover and then he gave another one.
That's really good. Okay, so Jesse, your best lap was 34.59, which I believe puts you in second. Well, I was going to say puts you in second place, but then it looks like Yvonne did a 34.04, which puts her in second place after Brandon. So all doing well. Everyone's finishing, which is fantastic. Okay, thank you, racers. Next up is going to be James and Aldo. And on deck, we're going to have Checo and Nathan, so get ready. So James and Aldo, please log on. Yvonne, Jesse, please log off. Okay, James is in the outside lane, or I guess inside lane.
Yeah.
And now just waiting for Aldo. Aldo, I assume you're here. James and Aldo, please unmute. Aldo, going once.
Hello.
Aldo,
No,
are you looking for Aldo? Okay, Aldo is a no-show, so we're going to move to Checo. Are you or Sarah, as you prefer? Are you ready to go?
Sarah, are you there?
Yes.
Okay.
Okay, Sarah, could you please join James instead? Aldo's a no-show, and he'll get another chance in the next round. Okay.
Haru and join James. Got that? So I'm side lane always.
Okay.
Racers, are you ready? James, Sarah, you need to say yes. Are you ready?
ready.
Can you hear me?
Yes, now I can. Sarah, you ready?
Yes.
Very good. Okay, timers, are you ready?
Yes.
On your mark. Get set, go. Okay, they both start at the same time. James is in the lead, so I'm going to have James. Could you say a little bit about your technique and perhaps a little bit about yourself? Are you a student at UCSD as well?
Yeah, I'm a student at UCSD. I'm a computer engineer. So not MAE or EC. But I did a lot of what everyone's already talked about. But I think the main difference is when I approached the corners, I rapidly tapped the brake rather than doing a hard pull on the brake. And I think that helped my car handle the corners better, although I do cut the corners a little too hard and could not figure out how to untrain that. But I think I tried to move back and forth between the lanes enough that it would understand, like, it would understand how to handle both lanes, so I didn't have to worry about that.
Yeah, I can see your car is doing something closer to what one would call a racing line than just purely sticking to the yellow line, which well, you're in the lead, so it's obviously doing well. Sarah, tell us a bit about you and your technique.
Hi, can you hear me?
Mm-hmm. Yeah.
I'm a grad student at UCSD. I completed my undergrad here as well, and my specialization is in robotics. So this is one of my first quarter taking robotics classes, but I have some experience in machine learning. Obviously, this data was created by me, and I'm not a very good driver on the player control, at least. So my data consisted of me using a very low throttle output and trying to drive consistently in between the lines.
So this is a very common and clever technique, which is just to be conservative for the first one and get some points on the board. Sarah, do you think that you could turn your throttle up for the second run and your model would still perform?
So I did turn up the throttle for this, actually, compared to what I had done for the training. And I can try, but I'm not sure how well it will perform.
Well, you've got points on the board, so there's there's nothing to be lost. Cranking up and see how it goes. Okay, so Sarah had a decent time. Best time was 38.94, and James is oh my goodness, 31.36. That's first place. Fantastic time. So that racing line shows its worth right now. Bravo. So things will change over time, but right now James is in first place. Next up, we have Nathan and Ayush. Nathan and Ayush, could you please join? And on deck, we're going to have Jared and Blake. Nathan is on. And Ayush is as well. Okay. Racers, are you ready? Please unmute.
Nathan's ready.
Ayush is ready.
Timers, are you ready?
I'm ready doing Nathan.
Ready.
On your mark. Get set. Go. Okay, Nathan is first off the line. Nathan, tell us a bit about yourself and your car.
Okay, so my main strategy was basically to follow the racing line as close as I could. And I feel that decreased my time pretty well. I found the best settings to use are pretty high steering sensitivity because it lets you get around the tighter corners a bit easier, and like a medium-ish throttle because you kind of want a slower speed just to be able to control yourself, especially on the turns.
So I can see that your car is aggressive in its steering. Like sometimes it follows in a racing line, like right off the course. That's fine, by the way, as long as you don't miss a cone, you're good. So like I can see right now. Well, you just missed.
Well, that's not normal. Oh no.
Yeah. Okay. Well, that happens. It doesn't matter. You got points on the board. Aish, let's hear more about your car.
Sure. So this is probably my most conservative model yet. Going at a super low AI throttle multiplier just to make sure I can finish the first lap, and then second time I'll crank that up. This is probably my fourth working model. My first one, I was trying to drift around the corners, and that doesn't really work with a kind of a linear trainer. And then my second one, perhaps maybe too much data, and it just always went in a straight line. So that one wasn't the greatest either. And I kind of settled on this one where I trained as clean of data as I possibly could. So kind of slower, sticking kind of to the middle, but trying to make those turns as sharp as I could to shave off some time.
You use the phrase linear trainer, I think. Can you explain what that is?
Yeah. So the model at the end, you can specify how you want to train your model, like linear, quadratic, and I think there's a couple others in there. And we were kind of using the linear trainer. And I'm not too sure.
Jack, can you bring back the track in the screen? Can't time it. It's a bit urgent. Sorry about that.
All right. So I believe that, okay, so Nathan got points before he hit the cone. And so we just have the one lap of 34.46, which is a very decent time. And Ayush is 42.75 for the second lap, which is very good.
Chris, what I'm doing is that if someone misses the second lap and still can complete the third lap, then I put it back as being valid because I clean up that so they cross the line for the second lap, even though it was not valid, and then I reset and say, hey, okay, I'll give it the third time.
Sounds good. Sounds good. Okay, very good. Thank you, racers. We're now up, Jared and Blake. You should now be joining. And on deck is going to be Philip and Dallas. So Jared and Blake, please join. Philip and Dallas, get ready.
I am connecting.
Okay.
I should be in there too.
All right, we'll wait for Jack to sit. There you are. Okay, racers, are you ready?
Yes.
Yep.
Timers, are you ready?
I am. I'm doing Blake. By the way, so what I do, I time out of my own feed versus the one. Yeah, anyhow.
Okay.
Okay.
On your mark, get set, go.
All right.
Okay, Jared, you are the first off the line. Tell us a little bit about yourself and your car.
My name is Jared Benj, and I'm a mechanical engineering major at UCSD, and I'm doing a specialization in controls and robotics. As far as like my model goes, I started with small data sets so I could train it locally on the virtual machine. And then after I got a working model that was working off of just like I think like a couple thousand data sets, I decided to train it a little bit more and add more data. But the computation time took very, very long. So at that point, I moved on to the GPU cluster and sent the data over there via SSH and trained on the GPU cluster. It only took like a few minutes, even though I had like 20,000, 30,000 data points. And as you can see, it does a pretty good job at following the line, and it goes pretty fast. And the way that I made it go a little bit faster is I turned up the throttle configuration in the my config, and then reduced the joystick sensitivity so that at high speeds I had a little bit more control when driving. And that's kind of what I did. And also to make it so it could start on the left-hand side of the track and the right-hand side, I recorded data points starting on the left and right about 10 times each.
Excellent.
So it should be pretty stable no matter what side of the track you're starting on.
You mentioned a GPU cluster. What is that?
So UCSD has a GPU cluster that is used for like grad students and also for 148. And essentially when you log into that, they allocate, I think it's like 4 CPU cores, 16 gigabytes of RAM, and a pretty hefty GPU, like NVIDIA GPU. I think they have like 1080 Ti's and 2080 Ti's and Titans. So they're pretty powerful. And it really helps out with doing the computation, because if I didn't have that, I wouldn't be able to run those 30,000 points that well. So yeah, it's been super helpful.
Terrific. Blake, I guess you're our other racer. Sorry, we went a little long on that, but can you tell us a bit about your technique?
Yeah, so I also did multiple models, and this is the one I decided to go with. For this one, the big differences I did between this one and my earlier models was I decreased the max AI, like max throttle by a lot. I think it's at like half speed. And I decreased the joystick sensitivity to like 20 or 30% of the max, because I really didn't like the jerky movements I was getting while training. So I wanted to like follow the yellow line and try to make it really smooth. So that was kind of the goal of this model, was to just be like really conservative, just stay on the yellow line and not have jerky movements. And this only has about 30 laps of training data, but it can go for much more than 3 autonomous laps before messing up. So I was happy with that.
And you got a decent time. 34 is your best time. So that shows it's a good conservative approach. Presumably you're going to crank up your speed for the next round. Okay, good. Next up is going to be Philip and Dallas, and Haru and Pratik are going to be on deck. So Philip and Dallas, please. Blake and Jared, you can log off.
Yeah, disconnecting.
Philip and Dallas, you can log on.
Hey Jack, Dominic here. I can take over your timing if you need me to, so you can do some other stuff.
No, I'm good. Okay. Thank you.
Okay, Philip is in and Dallas is in. Okay, racers, please unmute and tell me, are you ready?
I'm ready, yes.
1 second. Okay, I believe I'm ready.
Okay, timers, are you ready?
I'm ready, doing Dallas.
Okay, on your mark, get set, go. Okay, both started exactly the same time. That's excellent. Oh my goodness, and they crunch. Okay, we're going to restart this one.
Okay.
So racers, log off and log on again.
So if this happen again, I have a hint for you. Just wait for 1 second or so.
Yeah.
Even if someone going in front of you, because you're racing against the time or your own time. So.
Okay.
I'm having trouble. Oops.
Gotcha.
I'm having trouble. My control C doesn't remove my car from the track.
Okay, so let him time to reset that. Hold on.
I'm not sure why Control C doesn't. It should just stop the thread. Okay, this looks better. So we have Philip and Dallas. Okay, racers, are you ready again?
Yeah, I'll wait a sec this time.
Okay, and
okay, for sure.
Timers, are you ready?
I am doing Philip. Yep.
Okay. On your mark, get set, go. Okay, Dallas goes first. Give him a little time. Okay, Dallas, you went first, so tell us a little bit about your car and yourself.
Yeah, of course. So I am a transfer student at UCSD, transfers from a community college over in LA. And yeah, this class was awesome because like I've wanted to do robotics since I was a kid. So when I saw this, I'm like, oh, I got to get in that. And it's like super competitive at UCSD to get in. So when I got in, I was like super hyped. And yeah, I play like a lot of racing games like Forza or like Dirt Rally or something. So like this was a really cool assignment to do. And my strategy here was just to, at first, try to replicate how I do it in those games. So find the racing line or like do a drifting model or something. And like the first model I did, I taught it how to drift, but it just like was completely inconsistent. And so I'm like, okay, there's a different set of rules to like how you make an AI model. And so the second time around, I made like super clean data. I tried to stick to the middle line, and then I had to turn my speed down like a lot. And just by doing, I think it was 15 laps, my model started working off of that. So
Yeah, you look very consistent. I can see you're conservative, but you can crank that up later. Philip, tell us about yourself and your car.
Hi, yeah, I'm an undergrad mechanical engineering student at UCSD. And so when I was training my car, I basically, I prioritized, I started with like a basic line follower, like a lot of people here, but then I kind of prioritized making sure that all my turns were as like gradual as possible. So like as I approached the white line, I would intensify the steering and ease off the throttle harder to try to make it more flexible. And also add like little bit of wiggle in some of my data to make sure that like on the straightaways it was ready to correct for if the angle was a little bit off, a little bit more flexible.
Very competitive. The two of you are pretty much neck and neck. But we're now done. Okay. So I think of the two. My goodness. So Philip, you were slightly. No, sorry. Dallas, you had the best single lap time with 35:16. Philip, you were just a tenth of a second behind at 35:25. And but both solid. I know you can both crank it up for the next round. Okay, Haru and Pratik are next. Haru is a returning racer. We want to hear what he's been doing differently. And on deck is going to be Matt and Ryan.
Dominic, can you take over my timer?
Dominic, you mean? Okay, so I'm doing Haru actually. Then you do Patrick, Dominic, all right? And I'll do Haru. Hey, Chris, just inside information, whoever can beat Haru, get a boba drink from me. Haru is one of the tutors for the class. And then also Dominic that's joined us is a tutor. So the expectation is that whoever can make, beat Haru basically at this point can get a boba drink.
Beat the TA, love it. Okay, Haru and Pratik, are you ready?
Ready.
I need to hear another ready.
Yes. Ready.
Okay. All right. Timers, are you ready?
I am ready doing Haru.
On your mark. Get set. Go. This is beat the TA. TA starts fast. Okay, Haru. Tell us what you've learned over the many races. How are you going to win?
I'm taking a different approach today, where I'm doing basically a more conventional approach, like without a neural net, and the robot is treating this as more like a localization problem, where you're going to be answering like a couple questions. Like first is where you are on the track. The second is compared to the optimal racing line, like how far off left or right you should be. And then the third is what control effort you should be using to like reach that like optimal racing line. And that's what I'm trying to do here.
How do you know where you are on the track?
Yeah, that's a very good question. And I definitely take advantage of a lot of those data provided by the simulator, for example, such as the XYZ coordinate. But there's a lot of processing going on also on the back end to figure out like what that XYZ actually means in terms of positioning on the track, like how far off you are to the center, and like where is the apex, those sort of things. Like you really need to get the optimal racing line going.
So this is a technique you could only do in the simulator. It wouldn't work in the real world.
Well, in the real world, if we're doing, say, like an outdoor race, we could definitely use a GPS. And then we also have some OpenCV pipelines set up to also get information from the image. We have, I believe I still run an AI model that actually upscales image from the simulator because it was of poor quality, coming at really low res. And I did some upscaling and try to extract like lane information from that, and it's been really helpful.
So given that you already know the XY position, why do you need the imagery at all?
Yes, just so you know, it's just an extra precaution, and also like in term when you get into a collision, like we have the image data, like you know you will get into collision when you have like obstacle in front of you or another car in front of you, and you will instantaneously recognize that and maybe pull some reverse on the throttle to get out of it. Yeah.
Got it. Excellent. Pratik, you've heard how the TA does it. How do you do it?
I have more like a conservative approach to this. Try to stay more on track while training, and I've also focused more on having a constant throttle, and I do apply some brakes on turns, but yeah, I think that constant throttle kind of gave me better results for the training data. Also, I did try like collecting training data while spawning on up to like different positions. Like when you finish a lap, try to finish it on a different side of the start point, and then keep going on so that you can have your car like go through all the starting points.
Smart. Good. Okay. I don't have, I do have Haru's time, and which is excellent, of course, as you would expect, 31:57, but not the best time, I think, out there. I think we have, so Jared has a better time and would get a boba if things continue this way. James has a better time and is boba ready as well. So I can think at least two people are ahead of the TA right now. So Haru, you're going to have to step it up if you, unless you want to be dishing out drinks for the rest of the week. All right.
Well, I'm not paying it.
Well, actually, I forgot to tell. I forgot to tell her who you are, just to put some pressure. It was just a small detail.
Okay. Whichever timer was doing Pratik, could you please enter into the spreadsheet?
So he cannot enter that. To Haru, we're going to have to read back to me, Dominic. What's the time? First lap.
Yeah.
Second.
So first lap 1, 38.86. Lap 2, 36.16. And lap 3, 36.94.
Excellent. Okay, so Matt and Ryan, you are next up, and Paul and Michael, you are on deck. So Matt and Ryan, could you please log in? We've got about another 10 to go, and then we'll go into the second heat. Matt and Ryan, log in. Okay, Matt's in. Waiting for Ryan. Paul and Michael, you should be ready to join as soon as these guys are done. Ryan, are you with us? Okay.
Yeah.
You are? Okay. Just waiting for you to log in. Ryan, how's it going?
Pretty good.
We don't see you yet.
Ryan, did you start your model already? Ryan, did you start it?
Yeah, it's starting.
Okay.
Okay, I see. Okay.
All right, there we are. All right, racers are ready. Timers, are you ready?
I am, and I'm doing math on the inside lane.
Very good. On your mark, get set, go. So Ryan, if I'm not mistaken, is a returning racer as well. So Ryan, why don't you tell us a little bit about yourself and your car?
Okay, so I'm a high school student, so I'm around 16 right now, and my car model is essentially just behavior cloning at this point, and I'm interested in learning more about like more complex neural networks.
Now you've raced in the past, I think. What's different this time?
This time on the corner, I focused more like the very sharp corner. I tried sort of a like of like a slower speed and see if it works better, and it seems to be a bit more efficient.
Good. For those who are not familiar with this concept, with these races, what the code that these racers are running is the same code that would be running on a real car. It's running on their local machine, their local laptop or desktop, and the simulator, which is running in UCSD on a server, is sending the images, pretending to be a camera. So the server sends images to your local machine. Your local machine interprets those images, turns them into driving commands, sends the driving commands back to the simulator, which then produces this model, the model cars doing what they're doing. So so basically, you're seeing a distributed, compute system here, and it could be moved over to the real world quite easily. It wouldn't necessarily perform as well, but it's the same code. Matt, tell us about yourself and your car. Matt, you're probably muted.
Yeah, it wasn't unmuting for me. I took a traditional approach with following the racing line, but I also thought about how we do this in our video games of the past. And so I took an incremental approach. I did maybe 5 laps at a time to train, and then I ran the model, see how it behaved, see what behavior I liked and what I didn't, and then continued forward with that. And that seemed to really produce the best results. Also, incremental approach with the overall speed of the model. I started very slow, and then I would gradually increase the throttle with each 5 lap trainings, and that actually really helped the model sort of get a feel for how to do it at a slower speed and at a higher speed.
Well, it worked tremendously well. You did a 30.93 best lap, which not only beat the TA, but would put you, I was going to say you were in first place, but unfortunately, Ryan did even better at 28.02, 27.24 actually. Is his fastest lap, which is extraordinary.
Yeah,
so,
check it out to the total time, Chris. Like several seconds. Yeah.
So reliable and fast. So Ryan, you're a high school student. Guys, I don't want to put any pressure on, but the high school student is crushing the university students right now, including the TA. So Paul and Michael, you are up next. And Timothy and Jeanette, you're going to be on deck. Paul and Michael, please log on. By the way, while they're logging on, the track you're seeing here is actually a photorealistically modeled version of the original warehouse where we did our first in-person races in Oakland. And you can see there's some actual spectators. Over time, we're going to add more spectators to it, just to kind of simulate the real world, and add a little bit more complexity, because the camera sees the spectators, and those obstacles, or those not obstacles, but that noise in the background could throw off a network if it wasn't well trained. Okay, Paul and Michael, you are in. Racers, are you ready?
Yeah.
Timers, are you ready?
I am. I'm doing Michael.
On your mark, get set, go. Now you'll note that the car models are slightly different this time. It makes no difference. It's just purely aesthetic, but it's fun.
Yeah.
And so Paul's running a little on the edge there, but he's back on. It looks like Paul's did not finish. I'm not sure, actually. We'll have to judge on that one. Michael's going slow and steady. Not even all that slow. Michael's going very steady. So Paul, what happened?
I did not train the outside lane. That's where I started from. Well.
Okay. So Michael.
Yeah.
Tell us about your car and yourself.
So I'm a freshman at UCSD, and I'm part of UCSD's Triton AI team. And this was also my first time racing, so I wasn't really sure like what worked and what didn't work. I used like the Triton AI team's like sort of donkey car framework, to do some basic behavioral cloning. I tried to go like sort of slow and steady. At first, I tried to follow like the yellow lines, but like I felt like that was a bit too slow. So I tried like driving in diverse ways, like on the left and on the right, with I think 16,000 data points. And yeah, it handles mostly well, except my experience is that like it's way more inconsistent on the server than on my local machine, probably because I tested the ping and it ranged from like 15 milliseconds to like 70.
Yeah.
So I think that's has a small impact, especially like on the curves where sometimes if there's lag, I sort of go too far out. But usually my car just like works fine because it's more of a conservative approach. Sometimes it goes out like that.
Yeah, exactly. So that's another a challenge, which is the latency of the network connection. And you know, the model may work perfectly on your own machine, may not handle the non-deterministic latency of the server, and that's something just to train for. That's part of the real world. Okay, we have some numbers in. So it looks like Michael, your best time was 38, and did Paul finish a lap or no?
No, I don't have a lap.
Okay, don't worry, you'll come
Are there
back.
like another change that I can finish one lap?
Yes. Okay, next up is going to be Timothy and Jeanette. So Timothy and Jeanette, if you could log onto the server, and on deck is going to be Steve and Dan. Paul, you need to log off. There you go. Okay, it looks like Timothy is in and waiting for it, and Jeanette's in as well. Racers, unmute. Are you ready?
Yes.
I'm ready.
Timers, are you ready?
I am. I'm doing TD.
Okay, doing genetic.
All right, on your mark, get set, go. All right, Jeanette, you were the first to move, so tell us a bit about your car and yourself.
I'm Jeanette Juarez. I'm a fourth-year mechanical engineering major. So when I was training the car, I actually did it at a slower speed. I was having a lot of trouble actually getting it done. I'm not sure what the issue was when I went back home, but there was a lot of lag with my controller. So when I would move the joystick, it would start looping around in circles, and I wasn't sure why. So I would have to press the e-brake. But somehow this model managed to work despite that. And I guess my other technique was that I would try to stay as close to the yellow line as well as others
Yeah,
did.
looks like it's working well. And so, Timothy, what happened?
I don't know. So this one is one of my first model, and it was the only one quite working. I tried. So this one is very simple. I just raced, and it was working fine. I tried some more intelligent models, and no one was working. So I just want to run this one today, and it's the first time he does this. So I don't know what happened.
Well, don't worry.
Chris, do you recognize the accent?
I do. Timothy, where are you from?
I'm from France.
Yes, we got that. Jack, was that what you wanted me to point out?
Yeah, exactly. I already connect him to Maxine. He does not live too far from Paris. He's a visitor student at UCSD, and then I'd already hooked them up.
Very good. All right. Okay, so Jeanette, I think this is the third lap, just finishing now. Is that? So that's a very reliable run. Was that 3 laps? Timer? Who's timing?
Yeah.
Jeanette?
So Timothy didn't complete, so I just put the timer in there already.
But for Jeanette, who was the timer on
Haru.
I'm doing it.
They're very good. Okay, excellent. Okay, Timothy and Jeanette, you can log off. Steve and Dan, log in. Jeanette had a solid time, 35. So now the track record at the moment is 27 seconds. So that's going to be the time to beat. So as we go into heat 2, which we will shortly, you guys, you're all going to have to, there's no point in doing another 36, another 37, go for it. Crank your throttle up because you've got 27 seconds to beat. And if you wipe out, oh well, but do something differently. Okay, Steve and Dan, are you with us?
I'm here.
Okay, timers, are you ready?
I'm ready.
On your mark, get set, go. Okay, looks like Dan, you're the first off the line. Tell us about yourself and your car.
I'm Dan. I'm a fourth year mech E major. So my strategy was just to stick to the racing line, and I was getting pretty good times with it. My car was a little too fast in the beginning, so I adjusted the throttle multiplier, the AI. But other than that, utilize the GPU clusters many others have, and I was really just going for the fastest time to get that free boba.
Looking good so far, very smooth. Steve, tell us about you and your car.
Hi, yeah. I am a student in the electrical computer engineering department, and this is my first robotics type course, even though it's been really fun so far. My car, I did kind of consider some of the strategies that have been talked about already, but mostly I think what helped me get my model to where it's at right now was just flipping on the TV and manually racing the car for maybe upwards to 45 minutes. And that kind of laid the groundwork for being able to complete a lap. And then upon watching it, seeing where it could use improvement, I ran a couple laps where I would hug a little bit of the outside of the curves so that it would not take them too sharply, and did some transfer learning on the car. And one option that I ticked off was freezing the last 3 layers, or having transfer learning affect only the last 3 layers. So that seemed to work pretty well.
You're both doing really well. I've noticed that no one's doing reinforcement learning. No one has done reinforcement learning yet. Jack, is that semester 2, or when do we get into reinforcement learning?
Sorry, on mute. We don't do this in this class, Chris. We don't have time for that. So we do the basically the neural net introduction, then we build the robots, see how the simulator go to the real world, and then we get into ROS, and then they have a final project. So we don't do reinforcement learning in this class.
Okay. Well, we may have some other racers who are doing reinforcement learning. Reinforcement learning. So what we've been hearing is behavioral cloning, where the AI learns from the human driver. Reinforcement learning would be one where you basically you tell the network what success looks like, staying in the lane, and you give it a reward function. And you say, look, keep running iterations, keep running around the track, and when you achieve the goal of staying on the track, that gets reinforced, and when you fail the goal, that gets punished in a sense, and it teaches itself. So if we have anybody using reinforcement learning, we'll get them to explain better than that. Okay, I think we finished there. So the times, how do they do? Wow, Dan did 26:33. That's first place. And Steve did, I'm not sure, did Steve finish his 3rd lap? Timer?
Yeah, I think so.
Oh, there it is.
Sorry, I forgot to update the value. Yep.
Yeah, no worries. Okay, very good. So we have a 26:33. Dan did amazingly well. So we're going to see him again, certainly in the ladder. Let's move to Jesus and Jack. Sorry, Zach. Forgive me, Zach Liu. Jesus and Zach, you're up. And then the last 2 will be Nathan and Ardell. So Jesus and Zach, please log in. Somebody needs to log in.
Let me try logging in again. I don't know why I appeared before. Be kind.
Okay, Zach is in, and Jesus is going to log in again. All right.
There we go.
Very good. Okay, racers, are you ready?
Aye, Captain.
Zach, are you ready?
Yes.
Okay, timers, are you ready?
I'm ready doing Zach.
On your mark, get set, go. Okay, they both start at the same time, which could mean a collision. It does in fact mean a collision. Okay, so let's racers law. Jack, are you going to reset the simulator, or should we have them log on off and on?
Oh, they already did before I could do anything.
Okay. All right. Okay, in this case, we're going to ask one of the racers to actually delay a little bit. Again, the time starts when you cross the line, so it's purely aesthetic. Jesus, would you delay when I say go, just delay a second before you?
Yeah, that's fine.
Okay, very good. All right, timers, are you ready again?
I am. I'm doing Jesus.
All right. On your mark, get set, go. So we've told Zach to go first, and Zach now goes first, and then Jesus is going to follow right afterwards. Okay, they're very good. All right. So Zach, tell us about yourself and your car.
Hi, everyone. My name is Zach. This is my last quarter at UCSD. I'm an EC major, specializing in circuit. How I trained my car was I pretty much trained it in the middle, following the yellow line. And for the straight line, I ran full speed, and then on the turns, I just slowed down and ran it. That's pretty much how I trained it.
Looks solid. Jesus, tell us about your car and yourself.
So this is again also my first year, an electrical engineer. And I first tried just going mad drifts throughout every turn, but at the beginning you could not get enough speed to drift in the first lap. So then what I ended up doing was, as soon as I'm approaching the starting line, I slow down significantly to be able to make the curve.
I noticed that you're spinning or drifting, I guess, a little bit. Is that working for you?
Yes.
Good. Okay. Well, it looks like Zach spun out, which is fine. He got points on the board. You can put Zach's numbers in 30 for 31 first lap, which is excellent. And Jesus is now, I guess, finishing his third lap, so you can put his numbers in. Very good, racers. You can log off. Zach got a 29 second lap, which is fantastic. And then I think a DNF on the third. We're going to put in Jesus's numbers. So Jesus used the drifting approach. Let's see how that did. We're going to put the numbers in. Did okay. 32.46. I think you can probably crank it up a bit more, given that 26 is the number to beat. And okay, racers log off. Nathan and Ardell, you are our last racers. Please log in. Okay, while we're waiting, Haru, you've got some competition here.
Absolutely.
Yeah, what are you
No
gonna
pressure,
do?
huh?
What are you gonna do?
Yeah, do something.
Well, trying something on my local end, and I mean, no pressure. I'm definitely doing something that's different, so I don't really expect it to like really perform that well. And it's like for me, like every time racing is like trying a different approach and see
What's the
works well,
problem?
what
Just
that-
paying 6 boba drink for the students. He doesn't mind.
Okay, we do have our last two racers, Nathan and Ardell. Racers, are you ready?
Yes.
Yes.
Timers, are you ready?
I am doing Ardell ready.
Okay, on your mark, get set, go. Okay, the time again to beat is 26 seconds. That's going to be something for Heat 2 and Heat 3. Looks like Ardell, you are in the lead. Tell us about yourself and your car.
Hi, I'm a UCSD student, once again, majoring in computer science. So for my car, I decided to go, my first model, I did something along with following the racing lines. So I realized like racing lines cut a lot of corners. So for my car, I decided why not cut all the corners possible. So as you can see right now, it's going through.
So that is very, very smart. It actually takes advantage of a glitch in our in our environment. We're supposed to put cones at every interior, at every concave curve.
Yeah.
And it just so happens we forgot to put one there, and you took advantage of that and you cut it, which is totally legal and smart, and bravo. And we'll probably have to put more cones in the future.
And one thing about this model though is it has high risk. There's a lot of crashing that could probably happen. So one thing I didn't do is make sure that to train my model to actually recover and reverse out of cones and walls if in case it did crash.
It's looking great though. So we'll see how that looks timing wise. Nathan, how about you and your car?
For this model that you're seeing, I decided to just go for the regular line following approach. Ardell, I did try something along the lines of what yours is doing, cutting that huge corner there. And I wasn't able to get it to work. So I really applaud you for getting that to work the way you wanted to. But just for this first one, I figured it would be safe to just run this line follower robot.
One of the challenges of cutting a curve like that is that you can't see the lines anymore. And if you just go straight and hope you're going to see the lines again, that works obviously. But in the real world, it might just be that your camera just doesn't have the right field of view, and you just never find the line again. So it's a little risky, but it looks like it worked really well. What? 24.6. Ardell, the last run of the day, gets the track record, 24.6.
Chris, just a moment. I see another racer, Andrew. Did you put your name in, Andrew? Are you racing or just listen to us?
I'm just here to observe and do some recording for content.
All right. Okay.
Okay. We did have one racer, it was a no-show, Aldo, but we're going to go into heat 2 and maybe Aldo will be back. So that was extraordinary, and 24.6 is, I mean, as far as that it might not just be the day record, it might actually be the overall track record. So that's a tactic. Turns out that that's one thing racers know is track tactics, and that was smart. And we're going to have to add more cones. So next time that tactic won't work, and we give you more challenge. Okay, so that is it. For heat 1, we're going to go into heat 2, Jack, can I suggest that just because we have so many racers that we just do one lap for the next 2 heats?
Okay, so basically you want to do one lap and we stop just the best time for the first lap?
Exactly, because we need to...
How about 2 laps? Because the second lap is usually faster than the first lap.
Okay, that's a good point. So we'll do 2 laps, but basically we're an hour in, and I'm not even sure we're going to get to heat 3.
All right.
So let's just do one more heat. We're going to do 2 laps each. This is like sudden death, and then we're going to go into the ladder. Okay, so starting from the top again, we have Albert and Jacob. Albert and Jacob, are you with us?
Yes.
So wait a minute, Chris. So I thought that at this point we just get to the top 8 to advance. Is this how you're doing?
Well, no, we actually, but that's not a bad idea. So if the top 8 is the ladder.
Yeah, why don't you do this? Just go to the ladder. This was the qualifying, because we won't have time to go another round like this. Just we sort, like you can get there now, sort, and then get to the top 8 and then move on.
Okay, it's well, before we do that, is there anybody who wanted to race who did not get a chance?
Okay, good point.
I know Aldo did not show. Was there anybody else who wanted to race? Speak up now.
To re-race again, you mean?
No, who did not get a chance to race. Anybody else who, or okay, anybody. So anybody who felt that their model just glitched and they could do they got like no points. So for example, Paul, you got no points. Timothy, you got no points, and Aldo, you were no show. So Paul and Timothy, if you want to race again.
Yeah, can we do that?
Okay, Paul, you're here.
Yeah.
Timothy, you're here. Okay, so let's do a final race with Paul and Timothy, just to give you a chance to get points on the board. So.
Oh, and Jack, can you find a second timer? Because I might need to do some work on the local end.
Dominic, are you around?
Yes, I'm here.
Okay, so you do the outside lane, I do the inside lane, and after you finish, you just read the times from me and then I'll add.
Tim, can I have the Tim, can I have the inside lane?
Oh, yeah.
Well, that's no good.
No, unfortunately, that's just the way it works. You get randomly assigned, and it's based on who logs in first. But it's part of the test is being able to handle different lanes.
All right.
So we'll talk about that.
Okay. So I'm waiting for people to log in again. Now you might get randomly assigned to the lane you want, but no promises.
All right, Dominique, I'm doing Paul because he's in the inside lane, all right?
Okay.
Even though look like on the left side of the screen.
Okay, racers, are you ready?
Wait, just a minute. Okay, I'm ready.
Okay, timers, are you ready?
I'm ready doing Paul.
On your mark, get set, go. Okay, Paul, you went up first. Now you were do not finish last time. What did you change?
I just switched to my conservative model and it just follows the yellow line.
Looks pretty good so far. And Timothy, what did you change?
Nothing. Like as I said early, it was the first time this model didn't work. So I just relaunched the same model exactly the same way, and this time it works.
Okay. Well, Timothy, you look like the more aggressive driver. So you're coming up on. We'll run the full 3 laps this time.
So Timothy's like Alan Prost then now.
Say again?
Famous F1 race, Alan Prost.
Oh, okay.
Yeah, and he was pretty good.
Not as good as Ayrton Senna, but it's okay.
What's the? All right, never mind.
Okay, so both of you are doing much better this time, and you're going to get points. After this race is done, we're going to pause for just a minute or two while we put together the ladder, and then we'll start and we'll do the best 8. Will go against each other. Okay, how are we guys? What lap are we on now?
Going to the last one right now.
Okay.
As soon as grass will finish. Okay, I got post times. I'm gonna upload to the spreadsheet.
Okay.
So I'm doing Paul.
Okay. Paul's times are conservative, but he did get times. 33 is actually quite a good time, better than conservative. Don't know whether you're going to make the top 8, but you're definitely doing well. And now, if we can just put in Timothy's times as well.
Yeah, I don't have access to the document, but I dropped his times in the Zoom chat.
Okay, just read them out to me and I'll type them in. What was the first lap?
First lap, 29:48.
Second lap?
26:45.
Whoa.
Yeah.
Third lap?
26:61.
Well, Timothy, I'm glad we gave you a chance to go again because you did really well. Okay. I'm gonna now set up the ladder. Jack, while I'm doing so, maybe you could take the downtime to talk a little bit about the course and what maybe those who aren't in the course who want to kind of follow along, how people could use the Donkey, go to the DonkeyCar site, load the simulator, basically how they can do it themselves.
Yeah, so we're going to start by saying, using Adam's favorite quote, is the real world of autonomous car. You don't have to spend any money to start if you just do the simulator first. And in the beginning, we did this because for the COVID-19 pandemic, as Chris said, and I actually now introduce as a part of my class because I think it does help the student to get ready while the robot's being built. So we started the class about 3 weeks ago. And then after the first week, people were already racing. And then the second week, we allow people to train faster instead of being 1 hour training on your CPU. If you have access to a nice NVIDIA GPU, you go there for be a minute or so. So sometimes it's like 50 times to 6 times faster if you train on a GPU versus training on a CPU. And then, of course, the next step is if you want to build your own donkey car for about $300 or so, you can have a reasonable good vehicle. You can even get there from less expensive robots that will be differential drive, not going to be necessarily the Ackerman string like as a regular car that you would drive, but you can use the same framework to do that. The framework support differential drive where you have the two wheels spinning this way, you go forward, spinning the other way, you go backward. If you go forward in one and backward in the other, you basically spin. So the framework does support there. So it's not very expensive to get in. Nowadays, the NVIDIA single board computers, it's between 60 and $90, depending how much RAM you want in there. And then you can get one of your old RC cars, another $10 for a battery if you don't have one, another $20 or so for the camera, and a new business, different by $300, you can get in business. So for the students at UCSD that maybe just listen to this, you just sign up for the class. And yes, you probably heard we have between 5 and 10 more students than we have slots on the class. Hopefully, if not this quarter, this coming quarter, you get to the next quarter and you get in, and then you have a chance to do what you just saw here using the simulator, using the GPU cluster for training. Then we build the physical robot. You try the Donkey AI framework on the physical robot in 2 tracks. One is indoor, the other one is outdoor. And then we go to ROS, and then you do the traditional computer vision programming on that same physical robot. And to wrap it up, you have 2 weeks to do a final project where we have to add some AI functionality to the robot or the mechanical aspect of it, and then we have to code for that. So that's primarily how the class look like. A lot of the students that you can see here, Andrew and Haru and Dominique, they were previous students on the class, and some of them come back as a tutors, and some move on to the real world on getting jobs in graduate school.
Excellent. Thank you. I've got the ladder set up now. Nope, let me see. I've just done something wrong. Bear with me for a second. 24.6. Okay, so, oh goodness, that doesn't work at all. Well, at any rate, the ladder, and Jack, you might be able, if you could just actually put the ladder on the screen, it's the 4th tab. Now, you'll see that it's the top 8. It is, it is extraordinary that I have to tell you guys that Haru did not make the top 8. What are we going to do about that?
He's going to do is playing a lot of bubble drinks and then get some pain and learn out of this. You always have to save your model to the competition. Then this is the nice thing, but nobody really remember that, yeah, I was trying this, Haru, this is a competition. I'm just kidding. But
now, in fairness, he was 9. He was 9th, but not in the top 8. So, there you have it. Okay, so the ladder, the way we work is we basically, we get the sort of the fastest within the 8 against the slowest within the 8, and then we just kind of match fast and slow together. So, ideally, these are the so-called, they're the starting positions. Ideally, we get the 2 fastest going head to head at the very end. So we're going to have, I guess it's going to be the best time, the best 1 lap time. So they're all going to run 3 laps, but the best 1 lap time will determine whether they move on or not. So the first race will be Ardell versus James. So Ardell and James, please join the server. And then on deck is going to be Ryan versus Zach. Okay. Now Ardell's best time, he is in first place overall. So the best time is Ardell's best time was, I believe, 24.6. So that is the time to beat. Racers, are you ready?
Yes.
Timers, are you ready?
Chris, just to clarify, we still take the 3 laps and the best lap advance, correct?
The best lap within the 3 advances, yeah.
Okay. Haru, are you back timing, and we still need Dominic?
Oh yeah, I'm back.
Okay.
Yeah, because you got nothing else to do right now.
Yeah, I
On your
thought
mark.
we were doing a safe run in the first turn, so I wasn't
Well, you
cranking out
know,
things. Yeah.
We changed the rules. Yeah.
you know, it's up to the racer. I would have done a safe run. I agree. If we didn't have so many racers, we would have done more heats. But you know, that's race day randomness for you.
What did we say one time from me? Chris said I'm the master of ceremony, can change stuff as I fit. So we change it.
Yeah. And you know, there's the next month. We'll see. Basically, if we have, you know, more than 10 racers or more than 15 racers, we're probably just going to do one heat.
Yeah.
So you can almost in the future, you know, if there's a lot of racers, just try to do your best with the first one. If there aren't a lot of racers, you have time to dial it in.
Yeah, Haru, we change that on the fly. Sorry.
Yeah, no problem.
It's just Boba. Okay, timers, are you ready?
No, it's more than Bob. It's bragging rights on the class. Yeah. They're going to have to hear this from a lot of students.
On your mark, get set, go. Okay, so one would expect, based on their position, that Ardell would win this one because he's got that very aggressive technique. Now the question is it going to be reliable? Is it going to be consistent? You know, is he going to be able to finish? And well, it's only one lap is what it takes, but we'll see whether it performs as well the second time. So far so good. Ardell's technique of cutting the corners is just working really well for him. Ardell, any changes?
No, it's worked. Don't fix it.
Yeah, if it ain't broke, don't fix it. And James, did you do anything to try to beat Ardell?
I did increase the max throttle to 1.0. I really only had it lower for that first curve where you can see I kind of cut it too hard, but I don't think that's going to be enough to make up for the, I guess you could call it the optimal racing line.
Yeah, at least for this day and this track, it'll change. We really have to put more cones up. I don't know what we did there. But there'll be smart techniques for the next track, and you know, we might put cones in the middle of the track, and you have to avoid it, and so there will be more challenge. Okay, so Ardell is lapping James. Look at that.
No kidding.
That has not happened before. Not today. Okay, so I think we know it almost doesn't really matter what the times are at this point, since Ardell has done at least one lap that's fast enough. Should we let them continue, or should we move on?
Let's move on. So while I put the times in.
EQ from James there.
Okay, so just for I presume since Ardell didn't change anything, his time was more or less the same. Did he do better than 24.6? Timer. Did Ardell have any laps better than 24.6?
Yes, 24.51.
Oh, very good. Okay. All right. Next up, so Ardell moves on. Next up is going to be Ryan versus Zach. So Ryan, Zach. You guys, you now can see what you're up against. So you're going to have to crank things up to move on. Okay, Zach's in. Waiting for Ryan. On deck is Tim and Matt. So Tim and Matt, get ready to come on next. Okay, let's switch back to the track. Okay, racers, are you ready?
Yes.
Timers, are you ready?
Yes, I'm doing Zach.
Okay, on your mark, get set, go. Ryan is favored as being rank 4 versus Zach's 5, but it's very close. These two should be. Oh no, Zach DNFs. Okay, that's as long as Ryan can finish one lap, he moves on. And Ryan finishes. Okay, we can call it for that one. Move Ryan on. Tim and Matt, you are up next. Ryan, you can sign out now. Congratulations on moving up. Okay, Matt is in. Timothy is, we're waiting for Timothy.
It's connecting.
Okay. All right, racers, are you ready?
Yes.
Yes.
Timers, are you ready?
Yes, I'm doing math.
On your mark, get set, go. Okay, they're going off at the same time, which could lead to a collision. Let's see. And, oh, just missed each other. Oh no, Timothy. Oh no.
Yes, tricked me.
Yeah, you were doing so well. Okay, well, Matt, if you can finish this lap, you move on.
Wait, I thought the rule was that like if both of them didn't finish, then there's gonna be a re-race if Matt doesn't finish 3 laps.
No, if both cannot finish 1 lap, there's a re-race.
Okay, I see.
But in this case, in the ladder, all we need is is 1 lap to move
ready.
on.
So
Okay, so Matt moves on. And Dan and Jared, you are up next. And Ardell and Ryan, get ready because you're going to be the next race after this. Okay, we have Dan and Jared. Racers, are you ready?
Yep.
Timers, are you ready?
Yep.
On your mark, get set, go. Okay, the racers. Oh, it might be a collision. Oh, so close. Oh, Dan pulls ahead. Oh, neck and neck. This is so exciting.
Oh,
Dan,
there we go. Yeah.
Oh no.
Tricked him.
Jared. Okay, Jared, if you can finish this, you move on.
Please don't spin out. All right.
And Jared moves on. Okay. Ardell and Ryan, you are up next.
All right, we got to get out of here.
This is the semifinals, the last 4. So the winner of this will go into the final. Ardell is up. Ryan is up. Racers, are you ready? Yes. Ardell, Ryan, you ready?
Yeah.
Okay. Timers, are you ready?
I am ready. I'm doing RCAI.
On your mark, get set, go. Okay. Oh, collision, and we're going to restart. Jack, can you restart the sim, or do you need them to log off?
Yeah, if I restart, they're gonna come right away racing. So they have to do that on.
Okay, so guys, log off, log back on. Okay, we have them in different lanes now, so this may lead to a different outcome. Racers, are you ready again?
Yeah.
Ardell?
Yeah. Can you hear me?
Yes, okay. Timers, are you ready?
I'm ready doing Ardell.
On your mark, get set, go. So Ardell's going to try to cut across the lane, and there may be another collision, but we'll see. Whew, just misses the cone. Oh no! Oh, just misses the tire. Ardell's really cutting it very close here. Oh, this is a proper race. Ardell's
pushing the envelope,
pulls it right behind Ryan. Slight bump. Ryan's taking the inside corner. Oh, it's neck and neck. Really aggressive.
Wow.
Ardell, they hit each other, and Ryan continues. Ardell is wiped out. Oh my goodness, I don't know how to call this.
They didn't finish.
Well, they finished 1 lap. So who did the first lap fastest? Timers, this is all on you.
How about if I said I missed that, Chris?
Oh no!
I did, because I was so excited looking, and then I said, I forgot to press the button.
All right, we're gonna do this again.
Sorry.
That was an awesome race.
Yeah, and then I started looking at it and I completely.
Okay, racers, log off.
spaced out.
Log off. And we're gonna log in again. This time the timers are ready for this neck and neck stuff.
Yeah.
Okay, now Ardell's back on the outside lane, so we'll see whether this leads to a collision. Timers, are you ready?
I'm ready doing RCAI.
On your mark, get set, go. Okay, I'm worried there's going to be a collision on this turn. Nope. Okay. So even Ryan is starting to cut that corner a bit. Oh no, Ryan's missed the turn.
Oh, he missed that.
DNF.
Yeah, that
So
doesn't count for first lap.
Ardell, if you can finish this, you're in. He finishes. Okay, so Ryan finished one lap, so he moves on. Ryan, I'm so sorry. You were doing great. All right.
Yeah, he wouldn't finish. Yeah. Okay. Anyhow.
Okay. Ardell moves on to the final. Now we have Matt versus Jared.
All right.
Okay, the winner of this will go into the final. Matt is, oops, we need somebody to, Brian, we need you to log off. Thank you. And it looks like Matt should log back in again because Ryan threw off his starting position. Matt, if you could log off and log back in, thank you.
Good call, Chris.
Okay. Racers, are you ready?
Yep.
Yes.
Oh, very good. Timers, are you ready?
Ready doing Matt.
On your mark, get set, go. All right. Jared heads off first. Jared, have you tweaked anything?
No, I just kind of kept it the same. If I increase the throttle, oh, that was very close.
It was
it usually
close again.
makes it drift a little bit too much.
Okay, we're going to restart on this one.
All right.
Racers, log off. All right. Racers, are you ready?
Yep.
Timers, are you ready?
Yes,
Yep.
ready doing Matt.
On your mark, get set, go. So these two races are very close. As a result, we're going to get high likelihood of collision again, but let's do it until they finish. So Matt takes the racing line, pulls ahead,
Ooh.
but Jared's going a little faster. So Jared's a faster car, but Matt has a slightly better line. We'll see how this plays out.
Yeah, it looks like he might throw me off too.
Oh, Jared pulls
there we go.
ahead.
I usually spin out on this corner a little bit, so he might.
Oh no,
hit
and
me.
did spin out on the corner.
Oh, let's save
Oh,
it.
just misses. Oh no,
Oh,
Jared.
no.
Jared DNF. So Matt, if you can finish, you are going to the final. Matt finishes, goes into final. So now it is Ardell versus Matt for the final. This is what. So you get Boba for beating the TA. What do you get for winning the overall thing, Jack? Jack, you got to be able to do better than Boba.
Don't know yet. Maybe you're gonna like one of those spring rolls along with the boba.
Spring roll. Okay. Very nice. Okay, Ardell and Matt, you are now okay, so Ardell's going to be on the inside lane. That's going to lead to some challenging lane crossing. Matt, if you could log in. Okay, racers, this is it. This is the big one. This is the final. Are you ready?
No, not ready.
I'm nervous, but
Are you at least ready to press the button?
yeah.
Yeah.
Okay, timers, are you ready?
I'm ready. I am doing Ardell.
Okay, we're going to do the full 3 laps if we can. On your mark, get set, go. Ardell starts so don't worry, Matt, it's all about the time. Okay, Ardell pulls ahead. That's looking smooth. Ardell does this. Oh no, did we lose a server glitch? No, maybe that's just Twitch. Twitch glitched for a moment there, but looking good. Okay, everyone's racing really well. Ardell's got 1 lap down.
Yeah, 28, 25.
Jeepers, crazy. Okay, Matt, you're gonna have to, your car's gonna have to do something miraculous here. I mean, you're so good and so smooth, and yet Ardell's got that tricky line.
$24.11.
Wow. Okay, that is really fine racing. Congratulations to everybody. And Jack, whatever you're doing in your class, it's really working. These teams they're using different techniques. They're not all identical. Performing really well. Almost everybody finished.
It's all about bragging rights over Haru, I think.
Yeah.
All right, I have the 3 laps.
Okay, and that's for Ardell, who then wipes out just in time. And Matt is now finishing his 3rd.
Where are we adding those, Chris, here, or we don't?
Where do we add it? Sorry, at the bottom?
Oh, I see.
Yeah.
So I missed the other ones then. Okay.
Okay. So I think Matt is done. So we can now declare the victor. Ardell, congratulations. You are the winner. Matt, you are the runner-up. Ardell, you are not only the winner, but I believe you set a track record. So that is something that everyone's going to have to beat, at least for bragging rights, next month. Jack, any last thoughts before we thank everybody and sign off?
Next month, we're most likely going to have different track. We try to race 2-3 times each track and move on for the obvious reason. We're trying to keep challenging you. And then as Chris says, I don't know if this class is going to be able to see when we add con and other things. We'll see. I mean, you also work on, we're going to have every month we have a race, so you have everything that you need to come back and race again for another 2 times. Chris, appreciate for actually I do have something, Chris. How about a quick introduction who you are for those of you that heard about the yourself drones? You talk about the legend right here.
Yeah, thank you. So so I 10 or 12 years ago started a drone community called DIY Drones, which led to an industry, and I'm CEO of 3DR, which is one of the companies that spun out of that. That worked really well. The notion of open source, so cheap and easy introduction to drones and autonomy back then. And now we're doing the same thing with cars because the necessary ingredients, the computer vision, deep learning, powerful signal board computers, all that are now in place. So we can do cars. Cars are more challenging because you're using cameras to navigate, not GPS. And as a result, they benefit from deep learning, which drones don't. So drones are classic control theory, cars are AI, and it's really allowed us all to advance our skills, to use the latest, greatest AI techniques, and feel like we're on the cutting edge and have fun at the same time. So that's the goal. We do it in person. Go to DIY-RoboCars.com to see an overview of the communities, donkeycar.com for this particular framework. Download the simulator, download the framework. You can try it on your own computer. You can try it on the servers as well. Jack, I believe that the UCSD server stays up, or am I misremembering that?
So it does not, because it's actually still in my office, but hopefully in a few weeks it's going to stay up 24x7. But every time someone needs it, just let them know.
And join the community on the Discord server. You'll find that on donkeycar.com, and you'll go to the virtual racing channel, and you can keep up with this. And when Jack starts the server again, the reason you would use a remote server is just to experiment with latency. Otherwise, it works exactly like it would on your own computer.
Just race against each other, that we need the server for obvious reasons. So everybody, I sincerely appreciate. We did well. Again, another victor for CCD. No pressure for Haru. He's probably going to have to step up his game next time. And I sincerely thank you, everybody, to come in the morning. I know Saturday is a day to catch up on some sleep. I saw some people 7 o'clock already here. I saw some people staying at 12 and 1 o'clock yesterday or this morning, depending how you say it. So it was pretty nice.
Thank you, everybody. Thank you, Jack. Thank you, racers. We'll be announcing the next date will be probably in about a month's time. So around the 20 something of February, but we'll announce that on the meetup. So if those of you registered on the meetup, you just you'll get the notification when that's announced. Thank you, visitors and viewers on Twitch, and we'll see you all next month.
Yeah,
Bye
for
all.
all the students, let's finish that. As soon as you saw that you advanced and were faster than Haru, send him a ping, you got a boba drink. So, and then for the Ardell, you got a boba drink and one of those, whatever they have on top of Express, a spring roll if you do that kind of stuff. Good job.
Good job. And by the way, I see that some of the racers wanted a link to the spreadsheet. We can probably, I'll post that in read-only mode into the chat. So if you want to just stay on the, racers, stay on the Zoom just for a minute while I post the link, and then you can get it. Thanks all.
Thank you.
Thanks, Chris.